There, Mr. Sutton here, bringing you the AB Calculus 2-4 Part 1 homework solutions on piecewise functions and the squeeze theorem. On this problem, we're trying to figure out the limit as x approaches -1 of this piecewise function. Now, just double checking, -1 is a border value here, so that means that we need to actually find the left and the right side limit by plugging -1 into both of these rules. So for the left side limit, we've got -1 plugged into this first function here, x over 2 plus 3 over 2. That's going to be -1 over 2 plus 3 over 2 if I plug all that in. And I'm going to simplify it just so I can compare it to something else. So this adds up to 2 over 2 or 1. Now we're going to plug -1 into the second rule to get the right side limit. So that's going to be -2 times -1 minus 6. And that'll be 2 minus 6, which comes out to -4. Now comparing these two limits, 1 does not equal -4. Therefore, since the left and the right side limits do not match, the overall right two-sided limit at -1 does not exist. For this problem, we're trying to find the limit at -1 for this piecewise function here. Since -1 is a border value, we're going to have to take the left and the right side limits at -1 by plugging -1 into each of these rules, the one rule coming from the left side and the other rule coming from the right side. So let's do our left side limit first. -1's getting plugged into this x squared piece here. So this is going to be negative parentheses -1 squared minus 2 times -1 minus 1. This is -1 plus 2 minus 1, which comes out to 0. Now plugging -1 into the other rule here to get our right side limit, 2 times -1 plus 2. That's -2 plus 2, which is 0. Since the left and the right side limits are both 0, since they both agree and are the same number, that means that the overall limit as x approaches -1 is also going to be 0. For this problem, we're trying to find the limit as x approaches 1 of this piecewise function. Since 1 is a border value, that means we have to find both the left and the right side limits by plugging 1 into both of these rules. So for the left side limit, I'm going to plug it into this top rule here. We'll have -2 times 1 plus 5. And that's going to give us -2 plus 5, which is 3. Next, to find the right side limit at +1, I'm plugging 1 into this second rule, this quadratic rule. So that's -1 squared plus 4 times 1 minus 4. That's -1 plus 4 minus 4, so -1 overall. 3 and -1 are different limits for the left and the right. So that means the overall limit as x approaches 1 does not exist. On this problem, trying to find the limit as x approaches 0 of this piecewise function. So that means because 0 is a border value, I'm going to have to find the left and the right side limits at 0 by plugging it into each of these two rules here. So first we'll do the left side rule that has a quadratic. So we've got -0 squared minus 4 times 0 plus 2. And that's pretty easy to calculate. That's just going to be 2, doesn't get zeroed out. Next up, we're going to plug 0 into the right side rule here, 2 cosine of x. Cosine of 0 is going to be 1. 2 times 1 is 2. So that's giving us a left and a right side limit that both match. They're both 2. So that means the limit overall as x approaches 0 is going to be 2. On this problem, I'm finding the limit as x approaches 2 of this 3-rule piecewise function. Taking a look at where 2 falls with my intervals, it looks like 2 is a border value between the second and the third rules. That means I'm going to have to find the left and the right side limit by plugging 2 into these two rules here. I'll do the left side limit first. So for that, I'm plugging 2 into this x cubed plus 2 rule. So 2 cubed plus 2, that's 8 plus 2, is going to be 10. Next, I'll find the right side rule by plugging 2 into this 5x rule. So we've got 5 times 2, which is also going to be 10. Since we get the same thing for the left and the right side, that means the two-sided limit at 2 is going to be defined. It's going to be whatever our left and right limit was, which is 10. For this problem, we're trying to find the limit as x approaches 1 of this piecewise function. 1 is one of the border values here between the first and the second rule. That means I need a left and a right side limit for this one. For the left side limit, I'm plugging 1 into this first rule that covers everything up until I get to 1. So that's going to be square root of 1 minus 1 squared. This is just the square root of 0, which is 0. Next up, I have to plug 1 into the second rule to get the right side limit. Now, when I do this, my second rule is just a constant function of 1. It always gives me 1 no matter what I plug into it. So the right side limit is just going to be automatically this 1 right here. Now, since 0 and 1 are not the same thing, since our left and our right side limits don't match, that means that my overall two-sided limit does not exist. For this problem, I'm trying to find the limit as x approaches 2 of this piecewise function that's got some interesting parts in it. Now notice that 2 is the border value between these two different rules in here. That means I have to find both a left and a right side limit at 2 and then compare those. So for the left side limit, I'm going to plug 2 into this first ln of x function. So I'm doing ln of 2 in that case. And I can't really do too much beyond just simplifying that. And I actually can't even simplify it. I mean, ln of 2 is just ln of 2. We can do the right side limit now by plugging 2 into the second rule. So plugging it into the x squared ln of 2 rule, that's going to be 2 squared times ln of 2. And that one we can simplify if we want to 4 ln of 2. Comparing the left and the right side limits, ln of 2 and 4 times the ln of 2 are not the same thing. So that means that the overall limit at x approaching 2 there is not going to exist. So that's going to be choice E, non-existent. On this problem, we have a graph of a piecewise function. So they're giving us both the algebraic and the graphical representation of this. And they want us to figure out the value of the limit as x approaches 2 of f of x. So in order to do one of these nested limits, we have to evaluate it from the inside out. So first we need to find the limit as x approaches 2 of this inner f function. So just graphically, we're just asking, as I approach the x value 2 from the left and the right, what y value am I approaching? So from the left and the right side, we appear to be approaching the y value 5 right here. So from the graph, we can say that the limit as x approaches 2 of f of x is 5. Okay, what next? So the key here is realizing that this little x down here, as x approaches, they're really saying as the input approaches a certain number. So in the first case, they told us what the input was for the inner function. It was 2. But now we've got a new input going into this outer function. So now the problem we're actually doing is the limit as x approaches this output here that we just found of 5. As x approaches 5, what is f of x, the outer f of x, actually approaching? So for that, we could look at the graph, except that the graph doesn't actually show us what's going on with 5. It's probably going to be close to 3. There's just the way this slope is going. We don't know for sure. So to do this, we have to actually use the algebraic part here, the piecewise function. Now 5 is not a border value. The only border value was 2. So for 5, we can actually just plug it straight up into the rule that 5 falls into, which is this third rule here that covers all the x values greater than 2. So we're going to be doing 6 minus 1/2 times 5. That's 6 minus basically 2.5. Which is going to be 3.5 or 7 over 2. And that matches up with choice D.